All right. In this video, we are going to do an application of centripetal force on somebody going in a circle. We did a Ferris wheel, but this time let's try something a little bit different, similar but a little bit different, where we have a fighter pilot and they're diving in a jet aircraft and they get to the bottom of the dive and they pull out of the dive. How much how many G forces would they feel? This is a centripetal force problem. So what we have is the plane, which is diving down, and that person decides it's time to pull out. When they pull out of that dive, and that's circular motion, there's got to be centripetal force acting on the person as we go in that circle. So let's say that they're diving in their plane, and they dive, and they get down to the bottom, and they have this radius of the turn at the bottom, 2,000 meters. And let's say they're in a fast dive. Maybe they're trying to get away from something. Maybe they're in an alien spacecraft. They gotta get away from the aliens. And they're moving at, let's see, 400 meters per second. It was a fast dive. And that's over the speed of sound, so it's pretty quick, 900 miles an hour. And they pull out of this dive. What would the amount of centripetal force be needed to come out of this dive, and how many G's would they feel? Talking about G forces, and what does that mean? All right, so let's see. The centripetal force is equal to mv squared over r. So you might say, well, what's the mass of the pilot? Actually, it won't matter what the mass of the pilot is. We can actually calculate this without it. But you know, sometimes people just want to have that mass of the pilot. I always use a 100. It's easy. So let's say the mass of our pilot is 100 kilograms. Okay. So in order to pull out of this dive going this fast with that radius turn, that mass, we're going to need a centripetal force acting on their body. And this would, of course, come from the jets and the elevators that cause the jet to turn. That's where the force would come from. So it would be a frictional force. So that Fc is equal to m b squared over r. Okay. So I'm going to do a little bit of faster math that way. This is going to be 16,000 divided by 20, or 616,000 divided by 2, or 8,000. That should come out to be 8,000. Check me though. Make like an Eastern European and check me. It's funny. But I think it's going to be 8,000. So this comes out to be 8,000. 8,000 newtons. Now, is that a lot? Well, this person, this 100 kilogram person, would normally feel, if they weren't turning, just standing there or sitting on something, they would feel 980 newtons. Or let's make it 1,000 newtons, make the math a little easier. This person normally would feel their weight, or approximately, we'll go approximately here, 1,000 newtons. Now this is 8,000 newtons. So 8,000 newtons is 8 times what they normally would feel. That is what we would call 8 G's. It's 8 times greater than their normal force acting on their body. So that's 8 G's. 8 G's, if you don't have a flight suit on, pressure suit, and you're not doing the proper breathing technique, you're going to pass out. But you could pull that if you're a trained pilot with a flight suit on. You should be able to pull out of that and be okay. But that is a lot of force acting on that body, moving that fast. It's a pretty tight turn for that fast. It'd be about 8,000 newtons acting on that person, and they'd feel about 8 G's, 8 times what they normally would feel. All right, another centripetal force application.